Good morning, class 9th. We have started with exercise 13.4 based on the surface area of sphere and hemisphere. We have done the first 6 questions. Let us do the remaining ones. Question number 7th. The diameter of the moon is approximately 1/4 of the diameter of the earth. Find the ratio of their surface areas. Assuming that moon and earth are spherical in shape, we will find out their surface area using the relation that we have just learned. To find out the surface areas, we require the radius of the spherical object. In the question, you've been given a relationship between the diameters of the two objects. So let us start by assuming the diameters for Earth and the Moon. Question number 7th, you have been given diameter of moon is 1/4 of diameter of earth. So I am just taking a representation for these. The diameter of moon, I'm using a subscript m, and for diameter of earth I'm using a subscript e. So this is what's given to you. The diameter of moon is 1/4 of diameter of earth. Let us assume that diameter of earth is x. Therefore, the diameter of moon will be 1/4x, 1/4 of the diameter of earth. From here, we can find out the radii of the two. Radius of earth, it will be diameter of earth divided by 2, which is x by 2, and the radius of moon, this will be diameter of moon divided by 2. This will be half of 1/4x. So this will be x by 8. Now let us find out the ratio of the surface areas of the two objects. Ratio of surface area of moon to surface area of earth. The formula for both will be 4 pi r square. So 4 pi radius of moon squared is to 4 pi radius of earth squared. These will get cancelled. Radius of moon, this is x by 8 whole squared, is 2. Radius of earth, it's x by 2 whole squared. To simplify, I'm going to write this as a fraction. So I will have x square over 64 in the numerator over x square by 4 in the denominator. Simplifying further, x square by 64, this is the numerator and this is the denominator. So numerator divided by denominator, division by a fraction. I hope you all know how to simplify the division by a fraction. This can be written as x square over 64 into reciprocal of the second one. Now simplifying, x square cancelled, these 2 get cancelled, so the ratio comes out to be 1/16. So hence the answer is 1:16. Question number 8. A hemispherical bowl is made of steel 0.25 centimeters thick. The inner radius of the bowl is 5 centimeters. Find the outer curved surface area of the bowl. If you compare this question with question number 5, in question number 5 you had to find out the cost of tin plating the inside of the bowl. So we calculated inner curved surface area using the inner diameter. In this question, you have to find out the outer curved surface area. we will be calculating this using the outer radius. But we don't have the outer radius, we have been given the inner radius. Along with that, we have been given the thickness. So using inner radius and the thickness, we can find out the outer radius, using which we can find out the outer curved surface area. So if this is the hemispherical bowl, then there is some thickness of the metal used. You have been given the inner radius. The inner radius, let's represent that by small r. Along with that, you have been given the thickness of the metal used. Thickness means this distance. The distance between the inner edge and the outer edge. This is given to be 0.25 centimeters. So this thickness is 0.25 centimeters and the inner radius is 5 centimeters. So from here you can see the outer radius will be inner radius plus the thickness. Let's write down. Inner radius, it is given as 5 centimeters. Let's represent it by small r. The thickness is given by 0.25 centimeters. Therefore, the outer radius, which we represent by capital R, will be small r plus thickness. You can actually remember this. You can write down a note that the thickness is given by difference between the radii. So if you have the circles like these, this is small r from the center to the inner edge. This is capital R from the center to the outer edge, and in between them, in between the two edges, this distance, this is your thickness. So the difference between these two will tell you what is the thickness. You can always use this relation if any of the values is missing. Using the radii, you can find out the thickness. Using one radius and thickness, you can find out the other radius. Now using this, we have 5 plus 0.25. The values are in centimeters. Be very careful. So this is 5.25 centimeters. The outer radius is 5.25 centimeters. So from here, the outer curved surface area of this hemispherical bowl will be given by 2 pi r square. Outer curved surface area using the outer radius. Now simplify. 22 by 7 is the value of pi. 5.25 squared. Let's simplify. Simplifying the square of 5.25, this comes out to be 27.5625. Multiplying it with 44 by 7, this is 1212.75 over 7. You can give approximate answer as 173.25 centimeter square. You can leave the answer in fractions, remove this point and this will be 100, reduce it to the lowest form, and then you can leave the answer in fractions if you do not want to divide. It's completely fine. The next question that we have is question number 9th. Let us see. A right circular cylinder just encloses a sphere of radius r. So there is a sphere which has been placed inside the cylinder. The cylinder is enclosing it. Enclosing it means contains a sphere. And the word they have used is just encloses. So it's the dimensions of the cylinder are just enough to contain the sphere. The size of the cylinder and the sphere are almost equal. Find the surface area of the sphere, the curved surface area of the cylinder, the ratio of the areas obtained in part 1 and part 2. They have also given a figure. Let's draw the figure and let us see what we can tell about the dimensions of the two shapes. So this is how the diagram is given to you. The sphere I have drawn with red and the cylinder I have drawn with black. The sphere just fits inside this cylinder. The dimensions horizontally across means from left to right will be equal and from base to top will be equal. The cylinder is able to completely fit the sphere inside it. That means the size of both is same, and the size will be measured horizontally and vertically. Let us see what we have. Cylinder just encloses the sphere. Therefore, dimensions of cylinder equals to dimensions of sphere, and by this we refer to the dimensions measured horizontally and vertically. Same for sphere as well. If we measure the size of the sphere horizontally and vertically, the size is exactly the same as the cylinder. So if I measure the size of the sphere horizontally across, this will be the diameter, and if I measure it vertically, this will also be the diameter. In case of cylinder, if I measure it across, this will be the diameter of cylinder, and vertically it will be the height of cylinder. So if we are measuring the horizontal dimensions will be the diameter of sphere equal to diameter of cylinder. And if we measure the vertical dimensions means for the sphere the diameter is equal to the height of the cylinder. So this means if horizontal dimensions are equal, this means diameter of cylinder will be equal to diameter of sphere. If the diameters of two objects are equal, then their radii will also be equal. This means radius of cylinder is equal to radius of sphere. The radius of sphere is given as r. Therefore, radius of cylinder is also equal to r. This was using the horizontal dimensions. Now let us see what happens when vertical dimensions are equal. Vertical dimensions are equal. Dimensions, by dimensions we mean measurements. So vertical measurements are equal. This means height of cylinder will be equal to height of sphere. So height of cylinder is fine, but we don't have height of a sphere. The height of sphere is diameter itself. Now this is important. If you measure the height of sphere from the base to the top, it will be equal to its diameter. Therefore, height of cylinder equals to 2 multiplied by radius of sphere. Once again, what we have, if the vertical dimensions are equal, that means height of the cylinder will be equal to height of the sphere. But there is no height of sphere. For a sphere, if you have to measure from the base to the top, it will be equal to diameter. For sphere, the parameter is just 1. We can only measure the radius. So if we have to measure from one extreme point to the other extreme point opposite to it, the measurement will be given by diameter. So the height of sphere will be represented by the diameter. Hence, the height of cylinder equals to 2 into radius of sphere. Why? Because the diameter equals to 2 into radius. So this becomes 2r because the radius of sphere is r. Using these, let us find out the surface areas of the two objects. First part, we have to find out the surface area of sphere. The surface area of sphere is given by 4 pi into radius square, and the radius is r. So this will be 4 pi r square. Now for a cylinder, we have to find out the curved surface area of cylinder. This is given by 2 pi multiplied by its radius multiplied by its height. Let's use the values. Radius of the cylinder is, we just calculated, radius of cylinder is r. The height of cylinder, it's 2r. So 2 pi multiplied by r multiplied by 2r. Simplifying, this comes out to be 4 pi r square. Now let us find out the ratio of the two areas. So 4 pi r square is to 4 pi r square. Answer of the first part and answer of the second part. These are equal, so the ratio will be 1:1. And this completes your exercise.